Hello, this is Brian Delurier, and this is my Lab 5 for Faraday's Law. So an introduction to the lab, the purpose is to collect time data of a magnet falling through an aluminum tube in order to help understand Faraday's Law and develop a computational model to better visualize Faraday's Law in action. Some of the concepts being used in this lab are Faraday's Law and Biot-Savart's Law, which you can see here to the right, as well as Newton's second and third laws. So these are the measurements I got when performing the experiment. I got the length is 0.3 meters, width is 0.006 meters, and that's for the aluminum tube. The inner radius is 0.02 meters, radius is 0.032 meters. Mu is 1.96 am squared. That's from a previous lab. I think it's lab 3. Mass of the magnet was 0.025 kilograms. The average time that I recorded for the magnet to fall was 1.246 seconds. However, in the computational model, it was a little bit faster at 1.15 seconds. And I did it 5 times to get this average time, and you can see that data to the right. This is just a screenshot of the model just as a little bit of an explanation. In the model in Glowscript, you can see the blue and red representing north and south for the bar magnet. And as time runs, the bar magnet falls through the tube. And the results can be shown here with the velocity versus time graph. And you can see after about 0.2 seconds, the velocity levels out as the bar magnet falls. The conclusion of this lab. So what is the resistivity of the conductor? What if the resistivity of the conductor were reduced as close as possible to zero? How would the dynamics of the falling magnet change? Because of Ohm's law, the induced current would be very large. This would make the time it takes for the magnet to fall through the tube to be even larger and the velocity of the magnet to be smaller. Essentially, the resistivity is reducing some of the effectiveness of the conductor to hold a current. And so if you reduce that resistivity, the current goes up. This means that the force acting against the magnet would increase, meaning that the magnet would fall at a slower rate. What if holes or slots were cut in the tube? How would this affect the ring currents in your model? The model would have less rings in the computational model than it does now. This would cause a reduced induced current as well as a reduced magnetic force. This would cause the time it takes for the bar magnet to fall through the tube to decrease. And then here is a link to my Glowscript code. I will also include it in a description to this video. Thank you.